Michelle Banger, Managing Editor of Quality. We're here at the Quality Show South, the Assembly Show South, and Adhesive and Sealants ASI. So welcome for everyone. And today I'm here with Coy Limon of 3D Infotech, and we're here to talk about inspection, automation, and manufacturing and quality control. So Coy, welcome. Thank you for being here today.
Awesome. It's a pleasure to be here. Thank you for having us.
Yeah, for sure. So can you give the audience a little background on your work and what you do?
Yeah, so I'm a metrology specialist at 3D Infotech. I've been working with 3D Infotech for 5 years, and I started out as an application engineer, doing demos for our automated solutions, going out to customer sites, doing some 3D scanning in that. And once I grew in that position, I got the opportunity to use that knowledge to be able to go out to customers now and listen to their issues and tap into my wide database of partners and solutions that we offer, and really be able to customize a solution to solve their issue. Mm-hmm. So it's really fun. It's a really fun job to have. Good.
Yeah. That's great. Yeah, for sure. So obviously it's such a big trend now to talk about automation and kind of all these different things going on. So to start with, so what are some of the biggest challenges for companies that are looking to automate more and kind of just go to the next level?
Yeah, so a lot of the challenges I see out there are, you have these companies that have been around for hundreds of years and they have these legacy systems. So they're kind of stuck in their rudimentary ways of doing their work. They're also, they believe in that technology that they currently have. So when you go to a company and you try to introduce 3D scanners and robotics and artificial intelligence, it scares them a little bit, So being able to educate the company on, the path that they're going to be going, where they're at now and where their end goals are, and how technology can really help them, get there. So, the legacy systems, those are one. And then another issue I see is with all of the data that we're collecting is, what do we do with all of this data? We have to store it, has to be put on a cloud maybe, people want to access it wherever. So, the legacy systems and then also the data storage, those are some two big issues that I see right now with the AI and the automation.
That makes sense. It seems like companies aren't like, sign me up for something new and different and unexpected, and they like what they're doing now. So
especially if you've been doing something for 50 years, it's like, I brush my teeth with this hand and now I go to here, everything's different. I don't know if the results are going to be the same. So it's a lot of hand-holding and working with the customer through each step and setting guidelines, not going into it as this huge project, but what are bite-sized pieces that we're able to manage in order to be able to make you successful.
Mm-hmm. Yeah, that sounds great. And along those lines, can you share an example of maybe a product that, or a solution that kind of did help and did work for a company?
Yeah. So one of the best examples I can think of is, there was a company that they were inspecting millions of parts a year. And the issue right now is, especially in like smaller towns, is the workforce. They don't have enough people, they don't have enough talent in order to get what they need done. So a company approached us, millions of parts a year, how can we do it? And so we actually deployed like a dual scanning with a pick and place robot cell, that uses like QR codes and different things like that to identify the part that is on the tray, and then also be able to pull whatever information pertains to that. So that could be like data or like dimensional inspections, it could be visual inspection, kind of whatever the customer's looking for. And now that runs as a lights out cell. So we have a robot just picking trays, and now that company of only 2 people, they're able to meet the demand of their suppliers and stuff to be able to get those parts out faster. And that is a project where they came with this really grand idea, and it was like, okay, let's back off. And we've actually approached it into different phases, and it's definitely ensured the success of the project.
Mm-hmm. Yeah, that makes sense. And that's great that someone was interested in this new technology and new methods, and not just like, we'll see how it goes, not ready yet, whatever. Wait to see what the other competitors are doing. So
definitely, it's with the technology, or with the cell phones and the digital everything. There's so much information out there, and as the technology of 3D scanning and machine vision, as those get more accurate, companies are starting to open up their eyes a little bit and kind of get curious of what other technologies are out there. So you're starting to see a little bit more inquiries of people just, hey, I want to put my toe in the water. Let's see what we got here. And then it's like, okay, let me back off. So yeah, it's getting really exciting in this industry.
Mm-hmm. Yeah, and I like what you said in the beginning too about how it's going to help make your job better and faster and easier. People like that kind of thing. Not just like, okay, I guess I have to do this, so I will. But
yeah, and a lot of the jobs that robots are doing are stuff that you don't really want a person doing, repetitive tasks, kind of menial tasks. Humans are much better using their brains somewhere else instead of just looking at a part for 8 hours a day. So, let the robot do that work for you.
Mm-hmm. Yeah, for sure. So we talked a little bit about AI, machine vision, getting better, but what's the most impressive application you've seen, and how do we kind of ensure accuracy in these kind of environments?
Yeah, so that's the difficult part, is to ensure the accuracy, and so there's different ways to control that. But one of the most impressive solutions I've seen is a company has to inspect thousands of feet of cabling that come out of the ground, and what they're looking for are defects, scratches, pitting, corrosion, rust, different things like that, and we're able to run that system through a machine vision system that's using AI to classify the defects. So it's not just saying this is a defect, it's letting the company know what type of defect they're seeing. And then as you feed it more images, it's able to learn, okay, this is a defect or this isn't a defect. So that really helps out with the accuracy. So with this example, the thousands of feet of cable, they had 2 people 8 hours a day just looking straight down at the floor, just looking for pits, all of that stuff, and then they'd have to write down the area. And this solution, they just run the cable through, it recognizes a defect, it flags where that defect is at. When they're done with that cable, they can just go back through their database and find out where that defect was at and go ahead and cut it out or repair it. And so, it's taking a inspection that was done by human. It would take them about 3 or 4 hours, and we've gotten that down to about 30 minutes. And it's over 12,000 feet of cable that we're inspecting. And so with that, these cables are coming out of the ground, right? So they're going to be dirty. So to ensure the quality and the accuracy of vision systems, you have to have a really good camera. So you want to get a camera that has really nice megapixels, right? To be able to locate the defects that you have, the sizes. So if you have really small defects, you want a really, tight megapixel camera. And then the other thing is the lighting conditions. So, the light can change from, morning to sunset if it's something outside. If it's more of a factory application, you can kind of build a box around it to control the lighting. But if you're not able to control the lighting, what you can do is you can feed the algorithm more images from good lighting, bad lighting, and as you feed it more images, it's going to keep getting smarter. So those are kind of the ways to ensure accuracy. You want a really good camera, you want to control the lighting, and then you want a really good algorithm to help you classify those defects.
Sounds good. Leave nothing to chance and make sure your equipment is good and everything. So
yeah, definitely. Lots of testing.
Yeah, makes sense. So now just to talk a little bit about AR, how is augmented reality empowering experts to improve accuracy and efficiency and quality control?
Yeah, so augmented reality, this is the newest player in the game. And so the really cool thing about augmented reality is you have your physical part in front of you, and you're able to use either HoloLens glasses, you could use a projector, you could use a tablet, or even a cell phone. And it's gonna use the CAD model and allow you to walk around that CAD model, and it's called active tracking. So as I move around a part, I'll be able to see where those components are on the part, where they're supposed to be located. And what that does is I don't have to look at drawings or prints and then go and count where the bolt holes are. I could just have it projected. Okay, put all my green screws in the green holes. And it almost gamifies it at this point, you know? So being able to have the work instructions physically in front of you overlaid on the part, you know, it helps with quality control. So the operator can physically see, okay, is the bracket there or the bracket's not there? Another area where it helps is in training. So if you're getting brand new assemblies in, I don't have to sit there and you don't have to mess up 100 times before it's like, okay, you got it right. With the AR technology now, if I put a bolt in the wrong hole location, it won't allow me to go to the next step. Or if there's a certain pattern that I need to do in order to tighten like a flange, it's gonna force me to do that certain bolt pattern. Whereas I could do it 100 times wrong, and now we have to go back and, you know, scrap all of those parts. So the AR is getting really exciting, and especially being able to use so much different technology with it. So it's not just the glasses, you know. I can have an entire aircraft and throw some projectors on it and be able to have the entire aircraft be assembled at the same time. Or we could just have smaller assemblies and use a cell phone to be able to tell us where those parts need to be installed as well.
Yeah, just the way you describe it makes it sound fun. Like, oh, match the greens, you know, and like you said, more of a game. So
yeah, no, it really does gamify it. You know, people, they don't like to write stuff and that, but if you can be interactive and colors and different things like that, it makes the job just a little easier to do.
For sure. So kind of with all these combined, you know, AI, automation, machine vision, all this huge amounts of data, how can engineers transform this information into like real-time decisions that actually drive quality and efficiency? Yeah,
so a couple instances that I've seen is in like reworking processes. So a company can, let's say for an automotive car door, they can go ahead, 3D scan the car door, and then in the next station, they can actually project like a color map, or they can project the dimensional analysis results onto it. And now that person, the operator, can see, okay, in this area, I need to bring out the sheet metal. In this area, I need to push in the sheet metal. So that's kind of like an in-process where you're using that data to help drive your manufacturing processes. There's also a lot of stuff you can do with, let's say like a hole size. So if I'm doing CNC machining and I'm supposed to be having the same diameter of a hole every single time, if I track that hole size through, let's say 1,000 parts, and I start noticing that at part 250, my hole size starts growing larger and larger and larger, I'm able to use that SPC trend data to go back and say, maybe we need to go replace our cutter, 5 months earlier than we are now, and save all of that scrap. So being able to use the SPC trend charts and use that for like tooling needs, that's a really cool application I've seen as well. And then also in castings, I see a lot in castings where they'll go ahead and 3D scan a casting, and now they want to CNC it out of a single block of aluminum or whatever. They can take that 3D scan data, feed it to the CNC machine, and now optimize the position of that part inside of the block to reduce the amount of scrap that they're needing, to reduce the machine time that is needed, and stuff like that. So, the SPC trend charts and stuff like that, they're really useful tools to kind of see, how am I looking in my manufacturing process, and then be able to catch those issues early and stop all of those back-end incurred costs like scrap and different things like that, rework.
For sure, yeah. No one wants any of that, so that makes sense. And then kind of just last question, looking ahead, do you think we'll reach a point where defects are eliminated before production even starts, and kind of what's next in quality inspection?
Yeah, so that's a tough one.
No
now
crystal ball.
Yeah, I always want to say, let's just build this part and now the car drives, on a CAD model, on a computer, but that's not going to happen. But we're getting closer, so by the use of using digital twin, we're able to go ahead and we can manufacture the same exact manufacturing site if a company wants to, make that manufacturing somewhere else. So that's going to kind of help with the robot programming, the layout of the area, kind of the efficiency of the whole entire facility. And then you have robot simulations, and you have gluing simulations and welding applications. And now it's getting exciting to where there's like de-warping software for like sheet metal that'll do like clamping and different things like that. So as the technology is growing, you see a little bit more of like, these like processes in the factory that are being done. So like virtual clamping was never done before, but now that technology is getting there, so now they can go and actually mimic what the sheet metal would do. So, we're getting close. I don't know, because there's like glue, if there's a temperature at this degrees or this degrees, it'll dry at different rates. So I think one day we'll get very close, but we're on the path there, definitely.
Okay, sounds good. Well, those were my main questions, but do you have anything else you want to add or think we should include?
Nope, I'm good. Yeah, thank you so much for your time. I really appreciate you having us here.
Sure, definitely. Yeah, so thank you. This has been an update from Nashville. So thank you all for joining us. And for more podcasts, you can always visit qualitymag.com. Thanks so much.